Hello students, let us do some numericals. Here the mass of the earth is 6 into 10 raised to 24 kilogram and that of the moon is 7.4 into 10 raised to 22 kilogram. If the distance between the earth and the moon is 3.85 into 10 raised to 5 kilometer, calculate the force exerted by the earth on the moon. In this question G also given there, 6.7 into 10 raised to minus 11 Newton meter square per kilogram square. So you have to write the given quantities. Mass of the earth is equal to 6 into 10 raised to 24 kilogram, or you can write M1 also, no problem. Then mass of the moon is 7.4 into 10 raised to 22 kilogram. The distance between both, we can take that as R, that R is equal to 3.85 into 10 raised to 5 kilometer. This is equal to 3.85 into 10 raised to 8 meter. Then we have the equation F is equal to G divided by R square. You have to substitute the values in this equation. 6.7 into 10 raised to minus 11 into 6 into 10 raised to 24 into 7.4 into 10 raised to 22, the whole divided by 3.85 into 10 raised to 8, the whole square. After solving this, children, you will get 2.01 into 10 raised to 20 Newton. This is the force. Listen, a car falls off a ledge and drops to the ground in 0.5 seconds. Let G is equal to 10 meter per second square. What is its speed on striking the ground? What is its average speed during the 0.5 seconds? How high is the ledge from the ground? Here it is given as a car falls off a ledge and drops to the ground in 0.5 second. From this we can write T is equal to 0.5 second, U is equal to 0. We have to find V. G is given as 10 meter per second square. So the first one, what is its speed on striking the ground? So V is equal to U plus GT is equal to 0 plus 10 into 0.5 is equal to 5 meter per second. That is the speed on striking the ground. What is its average speed during the 0.5 second? Here we are considering uniform acceleration. That's why the average speed is equal to V average is equal to U plus V divided by 2. U0, V is equal to 5 divided by 2. 5 divided by 2, that is equal to 2.5 meter per second. Then how high is the ledge from the ground? Third part, we have to find the height of the ledge. That means how much distance is travelled by that. S is equal to ut plus half g t square. You can write this as h is equal to 0 plus half into 10 into t square, 0.5 into 0.5 the whole square. So you can write this as 5 into 0.25, that is equal to 1.25 meter. An object is thrown vertically upwards and rises to a height of 10 meter. Calculate velocity with which the object was thrown upwards, the time taken by the object to reach the highest point. Here the object is thrown vertically upwards and rises to a height of 10 meter. This is moving in upward direction. So we can take the final velocity as 0. G is equal to minus 9.8 meter per second square and S is equal to S or H is equal to 10 meter. From this we have to find the velocity with which the object was thrown upwards. We have to find the initial velocity u. Here v square minus u square is equal to 2gh. V square 0 minus u square is equal to 2 into minus 9.8 into 10. Then here minus u square is equal to 2 into 9.8 into 10 minus 196. So u square is equal to 196. U is equal to square root of 196, that is equal to 14 meter per second. That is the initial velocity. Now we have to find the second part, the time taken by the object to reach the highest point. What is the time taken by that object, that we have to find. Here we can use the equation v is equal to u plus gt. You know v0, u is equal to 14, then plus minus 9.8 into t. We can write this as 9.8 t is equal to 14. Then time is equal to 14 divided by 9.8, that is equal to 1.43 seconds. This is the time taken by the object to reach the highest point. Calculate g. You can see small g there, that means calculate the acceleration due to gravity. Given g, capital G, universal gravitation constant is equal to 6.7 into 10 raised to minus 11 Newton meter square per kilogram square. Mass of the earth is 6 into 10 raised to 24 kilogram and radius of the earth is 6.4 into 10 raised to 6 meter. We have to find the acceleration due to gravity. So children, for doing problems, first you have to write the given quantities there. I am not going to write that now. I am going to substitute the values in this equation, gm divided by r square. Here you can see 6.7 into 10 raised to minus 11 into mass of the earth, that is 6 into 10 raised to 24 divided by radius of the earth, 6.4 into 10 raised to 6 the whole square. After solving this, you will get this as 9.8 meter per second square. You know this value, that is the acceleration due to gravity. Listen, here we have to prove weight of an object on moon is equal to 1 by 6 into weight of that object on the earth. We have to prove this. For that, some values are given there. Mass of the earth is 6 into 10 raised to 24 kilogram. Radius of the earth 6.4 into 10 raised to 6 meter. Then mass of moon is 7.4 into 10 raised to 22 kilogram. Then radius of moon is 1.7 into 10 raised to 6 meter. Now we have to prove Wm is equal to 1 by 6 into We. You know children, W is equal to M into G. You know what is this G? G M into G M divided by R square. So generally we can write this as G M divided by R square. Here we can consider M as the object of a particular, M is the mass of a particular object. That only we are considering here. Then we can write, from this we can write the weight of that object on the earth, We. That is equal to G into M E into M divided by R E square. Here ME means mass of the earth, RE radius of the earth. Now we can write the equation weight of that object on moon. That we can write as G into M mass of moon into mass of that object divided by RM square. Okay. Now I am going to write Wm divided by We. We have to substitute that expressions here. Then G into M into M divided by Rm square, the whole divided by G into Me into M divided by Re square. Here we can write this as M into M divided by Rm square. This Re will go to numerator. So, Re square divided by G into Me into M. Now we can cancel this G and cancel this M also. Now you will get M into Re square divided by Rm square into Me. Now we have to substitute the values in this. Here you can see 7.4 into 10 raised to 22 into Re square, 6.4 into 10 raised to 6 the whole square, the whole divided by Rm, 1.7 into 10 raised to 6 the whole square into M into E, 6 into 10 raised to 24. After solving this, here you will get this as 1 divided by 5.7. Approximately we can write this as 1 divided by 6. This 5.7 we can round off and write as 6. So 1 divided by 6. Listen here now. Here you can see Wm divided by We is equal to 1 by 6. So, Wm is equal to 1 by 6 into We. Weight of that object on moon is equal to 1/6 of weight of that object on the earth.